I hope most of you got a chance to watch Jensen's keynote. Gentlemen, please grab a seat, I would say. I think, No, I know everybody talked about, should we just wait, Jason, or because I know some of the people have just gone out, or should we just continue? I know some of you have probably heard Jensen today. Amongst many things, I realized what AI Factory is today. When I looked at that song at the end of keynote, I realized where's all the GPU going and the AI Factory is working. Rendering those heavy music, which was, by the way, I don't know if you all saw, was amazing, right? But jokes apart, as Paul and Alex alluded, DDN significantly investing our effort, time, resources in going out to the market to make sure that we deliver the value to the customers and work with the ecosystem. And really that's why this panel is a true reflection. If you look at it, kind of almost an AI factory, right? So you've got compute, networking, server side. You've got Accenture, which is the domain knowledge, application, and also the ability to scale and deliver some of these infrastructure scale. Of course, with DDN, which allows you to really power all that data in GPU clusters. So really, really look forward to it. You guys not seeing, thank you. Gentlemen, I think without much ado, if I was to, in 60 seconds, ask you all individually, what does AI Factory mean to you all? Chris, maybe I can start off with you.
Yeah, I think we've been hearing this a lot so far today. Everyone seems to have been able to absorb what Jensen's been talking about. We've been living this for a long time at NVIDIA, of course. But basically, AI Factory, you put in raw materials at one end and something of value, whether that's a song, whether that's something that's valuable to the world, whether that's something that's valuable to your business, maybe it's dollars, spits out the other side. That's really it. It's that simple.
Wick, yourself?
So for us, coming from the server background, the way I look at it is, predominantly you give it power and you give it data. And what you get is some kind of intelligence that you can use it to do whatever. Like it could be inferencing, it could be, let's say the models that will actually generate some cash for you or whatnot. But ultimately, just like any other factory, you have to give it some input, you are expecting some output. That's what it is.
Yeah, from my viewpoint, AI Factory is a purpose-built system where you feed it data and it produces actionable intelligence at scale.
With that leading question, for years we've been building high-performance computing infrastructure, right? With GPU, with CPU. But as you look at building, and most of you have been out there in the last few years, taking the initial set of very large GPU clusters now turning into AI Factory, what do you all have seen has changed, Chris, in your experience in the last year or so, as it relates to AI Factory?
In the last year?
Yeah.
Yeah, so we have a long collaboration with you all, starting back with our Selene supercomputer, which became the design for the DGX SuperPod, which is then expanded into this idea of general AI factories. And I think that is probably the biggest thing that's happened over the last year is this notion that a blueprint design is incredibly important to be able to create these large-scale designs. We used to just think it's just a large-scale GPU cluster. So we started solving networking problems. We started working with storage vendors and trying to create sort of a living thing that all functions together. And then having that be translated into being the way people are now doing AI. It's not just, hey, there's 10 computers in a rack over here. Everyone is doing data center-sized deployments to get their AI jobs done. And so that blueprint design that has turned into an AI factory, I think, is the biggest thing that I'm seeing versus individual siloed deployments that people used to do.
So good point. I think what I have seen is many people, when they started off designing these AI clusters, they came with the HPC background. And we know we've been designing for 20 years. We know what we are doing. Let's go and experiment with the whole networking piece and how the storage need to come into that. That's how it started. And it was a mess, colossal mess, mainly because think of this, right? When you're deploying something, you have to deploy it for scale. When you start off with some, let's say, a superpod, like 128 nodes, they start deploying, and they say, like, okay, let me put the leaf and spine switches whichever the way I want. That actually saves me a few dollars. great, it actually does it, but immediately after that, when they need to scale it to 256, all of a sudden this entire network need to be thrown out, and it's a big headache. That's number one. Second thing is the predictable performance. This is where the biggest problem that people ran into. When you're spending few tens to few hundreds of millions of dollars on an AI cluster, the last thing you want is to basically go and experiment on connectivity and see if it works. And if something goes wrong, who is going to take the ownership to go and make sure that it is going to be up and running? Neither NVIDIA nor Supermicro, none of us can really help in that in a meaningful time frame. So going back to your point is where the reference design or a blueprint that actually came into picture, which is the life of everyone. They hated it in the beginning because why am I basically driven in certain way? Until they have seen the result, then it's like, okay, it's all good. To just add one more point to that is the storage piece, which is again, people are trying whatever the legacy storage that they have because they have been using it for the object, file, block, whatever the storage that they've been using. But when it comes to AI, the workload is different, how it hits the drives is different, and what kind of performance needed is different. So this is where I think the validated design, including DDN working with NVIDIA and coming up with a blueprint, this is actually the one that actually have seen being used quite a bit more in the last year and a half than before.
Dave, what are you seeing from Accenture's point of view?
Yeah, it's a great point. So the way we look at AI Factory reference architectures, they're a very strong starting point. It doesn't end there. Why? Because the applications still need to be tested to drive that outcome. So at Accenture, what we're doing is we're basically wrapping pre-tested, validated designs, with DDN and team, that we know have a certain level of characteristics for performance, security, scale. But then more importantly, we have to look at the client's workload, whether you're in manufacturing, or life sciences, or retail, or edge, they matter. Because the workloads, for example, depending on the model that you're using, or the precision that you're using, whether it's FP16, 32, and now you're seeing NVFP4 that was announced recently. So on that core foundation, we don't want to spend too much time building the foundation. It's pre-tested and validated. It accelerates our time to value for our clients. Then you can get that achievable outcome. What we want to focus more on is how do we drive secure multi-tenancy? How do we want to provide scale, get observability, those type of areas, and not worry too much about what leaf port connects to a spine switch. Who cares, right? We assume that's going to work at 800 gig no matter what. So we're looking for predictable performance in a secure multi-tenant environment that comes out of the box, so we can now drive mission-critical applications for our customers. Our customers are enterprise, large enterprise specifically. A lot of the NeoCloud sovereign AI providers who are looking for the best performance at the lowest cost token. Call it tokenomics, whatever marketing term you like. But in a way that they can actually market this and provide a service to their end customers, because that end customer is actually the enterprise at the end of the day. So the enterprise is going to want the most efficient cost patterns for the infrastructure they're getting. The longer we wait in testing in the lab, the later time to market, and then the NeoCloud, obviously he or she has other competitors in the market. So it's a race to getting something into market quickly so we can drive business outcomes. And that's how we look at the factory model.
Dave, I wanted to stay with you because you from an Accenture point of view tend to work a lot with C-suite, tend to work a lot with the boards of the organizations and the enterprises globally. I just wanted to shift the gear from the infrastructure to the economics of AI Factory. What are you seeing, from Accenture's point of view, the C-suites of the businesses are asking in terms of the return on investment, in these AI factories? Are you seeing a pattern emerging? Are you seeing these are the discussions which are now becoming front and center?
Yeah, the three infamous words, ROI, will show up in any conversation with a C-suite client. But more importantly, what are they really looking for? They're really looking to really be competitive with their products or their services that they're offering their clients. And those clients could be humans, or they could be agents, right? We don't discriminate. Second is, they're trying to reduce their risk profile in the market. Whether you're a manufacturing firm, you're running oil and gas energy, or your financial services, you're trying to reduce your risk. And then the third is they want to provide a delightful outcome so that customers keep coming back to them. Again, human or agents. So reduce your risk, drive profitability, and then make sure you provide a delightful experience so they keep coming back to you for additional services.
Vic, Chris, anything you'd like to add?
So one thing that I wanted to say, slightly digressing, is that when we talk to enterprise customers, I mean, to be honest, majority of the deployments initially have been with like large-scale deployments for training clusters, and the NeoClouds are actually taking these GPU platforms and deploying. But when we started engaging with enterprise customers, one of the things that they see is they don't necessarily have data centers by themselves. They are working with some of the public, think of like co-location providers like Equinix likes, right? And so one problem is that this infrastructure that is available for them to host these GPU platforms aren't quite ready for the new infrastructure. Let's say, for example, the GB300s use power delivery using the bus bar versus the previous ones using the standard 60 or 100 amp circuits, versus the systems need to be operating in a limited power profile because nobody has infinite power. And liquid cooling is something that we are bringing into the platforms, which we started with a lot of resistance, but now it became de facto, especially given the GB200s and GB300s. So now what ended up happening is working with them and understanding the data centers, what they're operating in, which actually gave us a slightly different perspective as to how the enterprises are trying to catch on these things. And it's not easy for them because they are not used to thinking, at a hardware layer, but they need to, without them thinking about like what kind of hardware, where is it going, whether they are able to even deploy it or not. The rest of it is history. So this is where I think the whole AI factory, however the way, shape and form, is a small, medium, large type of t-shirt sizes if you were to do, they need to look at where they are deploying, how to engage with the suppliers from the very beginning, and go with the reference design so that they can deploy it easier.
Chris, anything to add to?
Yeah, I totally agree with both of those. And I think another dimension that I like to think about with these is maybe taking a step back or starting a little bit earlier and thinking about it in terms of your business planning and even planning what products you want to pursue, right? Nobody wants to build a factory that's outputting something that you can't sell at a profit, right? So you have to think about that from the beginning. It's simple CEO math, but look at it from the beginning of, is the thing that you're doing, the thing that you're pursuing, actually going to be profitable in the end? And that's why the tokenomics thing is so important. We're doing a lot of building, and we need to make sure that we're not building something that people can't afford to actually use.
I know there's some technical people in the audience, so imagine if there's somebody in the audience who got budget approved for $500 million to go build an AI factory. Chris, if I was to start from you, how would you go about, in 60 seconds, give them a high level, what are some of the key things they need to think about?
Yeah, I mean, I think it's the obvious things that people think about, compute, networking, data platform. Those are obviously very important. And then, again, just going back to the tokenomics thing, the shift to agentic AI is radically changing the amount of tokens that we need to generate, just the amount of traffic that we're dealing with, the amount of data that we need to keep in context. And so the context memory size is growing or making it pretty challenging for kind of what people were using general purpose storage platforms for. So we really need to look at that data platform layer and ensure that it's able to serve the AI factory to be able to meet these agentic workloads that are like dramatically increasing the traffic.
Vic, I guess is you guys.
I think workloads is absolute must, right? So the biggest problem that people are seeing is that if you take a look at even Haswell to Broadwell to every generation, the Blackwell, when you take a look at what is happening with Vera Rubin, at every level, NVIDIA is further tweaking the kind of support that's from FP64 to 32 to 16 to now 6 and 4. And when enterprises are taking their applications, they need to see which one actually represents what they're trying to do, because there is a resolution and also there is a performance. So obviously you want to make sure that whatever you're running is going to give a positive business outcome. If you're not profitable, then nothing else matters. But at the same time, many of them do not necessarily know what they would be using it for. That's where like Accenture will come into picture in providing a solution. Because this is without knowing the problem, how can you give a platform? And the second thing is that the sizing of it, which is compute portion of it. NVIDIA is like leading in like crazy, performance improvement generation or generation, like multifold, right? But at the same time, the interconnects, I'm not talking about within the GPUs within a system, but across multiple systems, and also the storage that go along with it, that becomes like super important. Oftentimes, storage is an afterthought in enterprises. This is going to kill them if they're not really thinking through. And this again goes back to think of like a blueprint, not just at a system level, but also at a data center level. What is that you are trying to do? What kind of networking and what kind of storage and how we are able to size it all together. This is extremely important, often overlooked, but this becomes our responsibility to go educate them, whether they like it or not, because this is going to hunt them otherwise.
Dave, would love your perspective from an Accenture.
Yeah, I mean, as we guide customers, we're spending a lot of time with them. Based on the business outcome, we work backwards. Typically folks just run after, like, what GPU bin would you like? What CPU would you like? How much memory? Okay, well, we tell them, there is no AI without data. So always have data in the back of your mind when you're building a system, right? That will drive different configurations of how these systems are going to be deployed. So obviously you need compute, network, storage. The orchestration is very, very important. I think it was mentioned earlier in the presentation. How these different components in the stack work harmoniously together as a cohesive orchestra, right? When you go to an orchestra, it's a symphony. Everybody knows what everyone's going to do at what particular time, and there's a beautiful outcome at the end, right? So it's a symphony we're going to. But more importantly, memory is becoming super important, specifically in inferencing, because it's very memory bound, and it's very latency bound, right? You have prefill and decode. Prefill is more CPU bound. So when you look at inferencing, if it's going to scale, we have to really think about memory, not just context memory. And memory is very expensive. If you're watching the price in the market for NAND and flash and things of that nature, HBM, yeah, they're going through the roof. So we have to be very, very conscious to cost as well. We can't gold plate everything. We'd love to gold plate it, but we can't. So what do? We have to tier. Just like NVIDIA has 4 different tiers of memory now. It's 3.5, which is the ICMS platform, the context memory solution. We have to be very careful as we're building a platform, what type of model it is, what's prefill, what's decode, and how much money do we really want to spend on data, and then have a path to keep adding additional data intelligence into the platform as our needs grow. So cost is going to be an important factor because that's going to affect tokenomics directly. So that's how we look at the entire system, and then how do we deliver it?
One of the things I wanted to touch, because whilst there's a lot of, I think one of the widely used terms, much like cloud or private cloud or hybrid, is AI factory, right? One of the things, Chris, maybe from an NVIDIA point of view, you can give us your experiences. Are you seeing any big differences, AI factory for a hyperscale versus AI factory for an enterprise?
Yeah, I think there's a deployment model that comes along with the idea of an AI factory for an enterprise, where it has to be more turnkey in that situation. For a hyperscaler, they're willing to go build their own software to sometimes create their own chips or interconnects, right? And complement what they can get from a commercial off-the-shelf vendor like us. But in an enterprise situation, you want to be able to have something that just works, is reliable, predictable, like we've talked about. And I think that's one of the things that's the big difference between those deployments. The hyperscalers have this incredible benefit that they can completely customize it, and they can spend almost endless time and resources doing that. Enterprises don't have that luxury.
Vic, what's your?
So I agree. So basically what's happening is that working with some of these large language model, think of like frontier model makers, so they use brute force method. They have like huge amount of infrastructure, and they keep taking the latest gear, right? But when it comes to enterprise, the budgets are fairly limited. And 2, most of the enterprises are primarily focusing on inferencing. They're not necessarily spending huge amount of resources on training. So they take some pre-trained models and then kind of put some guardrails and train them on their own data and whatnot and use for inferencing. So the way the AI factories, if you take a look at for enterprise, it's quite a bit different. The size is one thing, and more in terms of like what goes in that also is different. For example, you could be taking something with the GB300s, or you can go with the HGX platforms, based on the Blackwell, as well as going into RTX Pro 6000. So you need to look at what problem size you're trying to solve and what kind of performance that you're expecting, what's your budget, and several other things. It's completely changes the dynamics when it comes to enterprise customers.
Are you seeing the similar trend from where you sit?
Yes. One of the things, if I had to make an analogy, the enterprise likes to wear a seatbelt before they drive the car. hyperscale is pretty much a drag race for the most part, right? They're looking for the lowest cost per token, and they're going to go fast. I'm not saying they're not secure, but the enterprise, there's governance models, there's regulated industries, sovereign AI, so it's really important. Security by design, as I call it, right? That needs to be embedded into everything that we do. And second is the talent pool, obviously the enterprise, is obviously as now sophisticated. So things have to be more turnkey to the point that you made, so validated designs become super important. Topology-aware scheduling. It's a small little thing, but it's very important. Our enterprises don't have gobs of funds to build reserved instances and dedicated racks for specific workload. So we like secure multi-tenancy, and we want dynamic workload topology-aware scheduling, so I can drive higher utilization on the kit that I've bought, versus a hyperscaler. Typically, they'll buy reserve instances for a particular tenant or anchor tenant, et cetera. So cost is more of a factor as well, because they want to share the same infrastructure across multiple departments or multiple BUs. And then last but not least, the tiered storage and the data pipeline orchestration, which is extremely important. Cost is a factor in the enterprise, so we have to be just judicious on how we design those systems.
It'll be amiss on me if I don't talk about software. Whilst there's a lot of conversation on GPU and networking and servers and hardwares, if you would, but a lot of the value gets delivered from software stack. So, are you all seeing, what are some of the critical software layer which you all are seeing, which is kind of mission critical for somebody to run an enterprise, AI factory today?
It's funny you say mission critical. We have something called Mission Control, which is our software tool for managing these AI factories. And you're right, it's incredibly important to be able to do things like topologically aware scheduling, to be able to ensure that you're getting the most utilization out of your system. But it's more about a larger scale approach that you need to have, because you're now running literally a factory. Right? And so you have to be concerned, especially with the latest systems, with the complexity around power and cooling. You have to be prepared for any of the situations that might come up. So you need monitoring to be able to understand if there's potentially a leak or something like that could happen. All of these things are now things that you have to think about now when you're deploying systems that you didn't have to think about even 2 or 3 years ago. So that software layer isn't just about like, it's accelerating and providing things to the GPU at a certain speed and that sort of thing. It's also about the administration of the entire factory, ideally in a single place where you can see everything going on at once.
Wait, considering you all deploy so many AI factories, both at hyperscale and enterprise, are you seeing software becoming important for you all also?
Absolutely. So 2-3 ways. Let me look at it in the AI factory level. So when they are deploying the systems, initially they were all air cooled. Now they are, majority of them are liquid cooled, mostly hybrid, right? Mm-hmm. And let's say if you take a look at the large scale hyperscalers and whatnot, they have developed the piece of software to give them a single pane of glass to take a look at what's happening on, within the systems. On top of it, mission control is something that we are, proactively educating and then selling, which gives them an advanced telemetry into what's happening within the systems. But in many NeoClouds and others, what we are basically doing is something part of our so-called data center building block solutions. We call it DCBBS. Within that, we give them telemetry in terms of giving visibility into what's happening within the system, to the CDU, to the CDMs, what's happening within that, as all the way to the chillers, going out. So effectively, what it does is, I have seen cases where they turn off or reduce the water to the to the racks, and then eventually what happens is the racks will get overheated and they're just turned off, and people say, hey, what's going on here? The reason is the people who are managing the infrastructure and the people who are managing these chillers and whatnot, they are different people. So nowadays what's happening is all of these things we are stitching it together and giving the visibility. So no matter whether it's a data center operator on the infrastructure side or on the overall, let's say the HVAC systems and whatnot, they all have the same visibility, so they know if something is going wrong, how to do that. So software piece in terms of the AI factory management is absolutely important. Beyond that, of course, in terms of utilization of the GPUs and everything, there's like plenty of tools that are coming up on a daily basis.
Thank you.
You brought up a good point. Full stack telemetry or full stack observability, right? You can take raw telemetry, but you still have to drive insights out of it. So we believe in full stack observability. That's one. And observability is obviously for reactive issues, so you want to reduce your MTTR, or mean time to repair, as they call it. But more importantly, we want to use telemetry to be predictive and preemptive. So I want to catch things before they go wrong, right? To have an automated event-driven So I can publish a topic on a Kafka bus and be able to pick it up and in an automated system and remediate it before the problem ever happens. So let me give you a fair example. So if I'm getting telemetry from my CDU or the thermals in my rack, if I have rear door heat exchangers or have hybrid cooling, like in Blackwell, I know the thermal dynamics of the rack inside the cabinet. I know how fast my fans are spinning, right, directly relating to tokenomics. And I know how fast my GPUs and my network ports are spinning as well. Based on that, I can do workload management very effectively, triggering a northbound layer, because I can say, okay, well, this rack's running too hot. I want to be able to evacuate these containers and move them to another rack so I can drive containment. Because you don't want your GPUs burning out as well. We've seen a lot of failures, as you imagine. So that's where full stack telemetry from the infrastructure, we can actually impact workload. And if the workload is impacted, then your application is impacted. Because if somebody calls up a call center and saying, well, I'm seeing delays, you have no idea there's 3 fans over there spinning 30% faster. But guess what? That's what's causing the application to degrade. And the last but not least, in the observability side, what we truly believe full stack observability is for security reasons. We want to be able to see anomalies in the infrastructure because that is getting a piece of, it's like honeypot. People want to exploit it because they know if they can attract or attack an infrastructure, they can basically do bad things, right? You have a bad actor in your environment, or they'll just take you out of service. If you're a NeoCloud, that's real money left on the table. For security and then being predictive and preemptive, I would say are the 2 main things.
With that, I guess thank you, Chris, Wick, and Dave. Really appreciate your time. And for everybody in the audience, hopefully you got some insights, from these 3 gentlemen. Enjoy GTC. Hopefully it's fruitful for you all. Thank you again.